Hello and welcome to Yellowman Physics. Today what I want to do is look at one of the things that AQA have said will definitely come up in the June 2022 exams. So if you look at the advanced information they list, energy changes in the system is one of the topics that will come up. And in this video what I want to look at is just one part of that, which is the energy stores and transfers. Now, this energy changes in the system, they've said, will come up whether you're doing the Trilogy science exam or the straight GCSE physics exam. It also is common to the higher end foundation for the Trilogy and the higher end foundation for the physics. So no matter which flavour you're taking, this energy changes in the system is going to come up somewhere on paper 1. So it's well worth looking at. So AQA have come up with this concept of energy stores, and I'm not going to talk at all about how they've ruined a pretty good topic. But firstly, let's think about the 8 energy stores that they do recognise or want you to know. Okay, so first one is chemical. Now, a chemical energy store is anything that is a food or a fuel, something along those lines. I like to think of it as the 2 F's, so foods, fuels, and in those I'm including things like petrol, diesel, etc. And in foods I literally am meaning if you had a banana, that is a chemical energy store that your body is going to use. It's going to convert that chemical energy store into other energy types in your body. The one gotcha for this type is batteries. Really common misconception that batteries store electricity. They don't store electricity. Inside them there is a chemical reaction that pushes the electrons around the circuit. So one way I describe it is if I cut open a battery, and I'm not suggesting that you do, but if I cut open a battery, I don't spill electricity all over the table. The chemicals inside the battery will spill out, and I use that to remember the chemical. If you've ever left a battery inside something for too long, like a remote control or something, and you open it up and you know it's leaked all that nasty stuff, the chemicals have leaked out. Okay. Next type of energy store is thermal. So every object has temperature, every object can be thought of as a thermal energy store, but they like to talk about things warming up, cooling down. But let's give you some nice examples, like a cup of tea. Cup of tea, something that is warm, is a thermal energy store. Yes, it's losing energy from its thermal energy store as it cools down. That's fine. We can talk about how it's increasing the thermal energy store of the air around it. But nice example of something that's warm, thermal energy store. Elastic. So elastic is thought of as a store because I can take something that can be stretched, and if I simply leave it stretched, that energy is stored until I let it go and that energy is released or transferred. Now, one thing to note, I mean obviously, so elastic, we have to put Yellowman, or a rubber band, or a spring is probably the most common example. Elastic works both ways. So I'm storing energy when I stretch something. Be careful, if I squash something or compress something, I'm also storing energy in it, which will be then released when I let it go. So elastic can be extension or compression, long words, stretch or compress, I guess. Okay, I might just make a note of that. Stretch or compress. Better words would be extension and compression. So we've got chemical, thermal, elastic. Next one is magnetic. So something like the magnets on your fridge, they are thought of as an energy store because they're holding them there, and then you can knock them off and that whatever it is, that thing on your fridge, drops to the ground. Okay, so fridge magnet. Next one is gravitational. Gravitational is where you lift anything up, you're increasing its gravitational potential energy store. I can leave it there, still got that gravitational energy in its stored within it. I can let it go, and that gravitational potential energy will be transferred into other energy types, and in that case that would have been kinetic and sound, but we won't worry about those. So let's say Yellowman in a tree. So anything that's been lifted up, a book on a shelf, Yellowman on a mountain, an apple in a tree, your computer on your table, whatever. Electrostatic, bit of a new one for AQA really, treating this as an energy store. Electrostatic is where you transfer charge. It's the classic rubbing a balloon on your jumper and then sticking that balloon to the ceiling. So I'm going to go with balloon. No idea if that's how you spell it. And I might even try and draw a balloon, but that is going to end really badly because it will probably end up looking more like a fish. Now if I've transferred some charge, one side of the balloon will be slightly more positive. If I put it next to the ceiling, that will induce a negative charge here, and so the balloon will stick to the ceiling and it will stay there in theory as long as the charges can't balance themselves out. So after that we have kinetic, and this is movement energy. So I was going to go Running Man, but I've got a lot of that on here. Let's just go a car. God, that's really boring and physicsy, isn't it? A car driving along the road is a kinetic energy store. Anything that's moving is a kinetic energy store. So as Yellowman gets dragged across here, he is a kinetic energy store because he's moving. And then our last one is nuclear. And this is nuclear power. It's in the nucleus of the atom. So the energy stored in the nucleus of an atom, which can be released through radioactive decay or fission fusion, things like that. So we need a way to remember this, and I'm going to try and fit it down here. Let's see if we can. So I'm going to go cats take every meal gratefully, everyone knows now. Oh, that's perfect, isn't it? Let's just remove that from the bottom of there. So engrossed and right on here. Everyone knows now. So obviously this is all of it together. That's what it was intended to look like. Cats take every meal gratefully, everyone knows now. Chemical, thermal, elastic, magnetic, gravitational, forgotten this one already. Let's go electrostatic, kinetic and nuclear. Okay, let's get rid of that then. Now if we're happy with the concept of the different stores, I did kind of mention slightly when we were talking about them, AQA have this other idea then that there are certain types of energy or things that are transfers. So if I want to get energy from one place to another place, then this is a store, this is an energy store of some description. I don't know, this could be any of the cats take every meal gratefully, and then I want to get it over to here into this other energy store. And the way to get it from here to here requires some kind of energy transfer. Now AQA think that there are 3 types, but then it kind of extends down with a couple more. So let's just go, the normal ones that we're maybe familiar with are light, sound and heat. Or let's not call it heat, obviously, let's call it thermal. And then additional to these two are the concepts of work done and energy transfer when a current flows, an electrical current flows. So let's call it electrical current. Okay, work done is a force idea. I can transfer energy from one place to another by exerting a force. So this is me pushing something or lifting something. And the electrical current idea is the idea of me transferring energy from one place to another. Say to boil water in a kettle, I have to use an electrical current to transfer that energy into the kettle so it can then increase the thermal energy store of the water. So over here, light. So light is a wave. In fact, both of these are waves. So I might move energy from one place to another as a wave. And let's just do a wave across there. I might transfer energy from one place to another in terms of this thermal idea. It's the vibrations of the atoms from this place bumping into something here, bumping over into here. Now, I haven't seen a question yet about how they want this idea expanded. It seems to be at the moment, it's a bit like the traditional one where we just say for example, this is my cup of tea. And this is the room that I'm in. As the energy store, the thermal energy store of my cup of tea goes down, the thermal energy store of the room increases. And it doesn't seem to be that there's a lot of focus on this transfer idea. Not sure yet. But I could have a sound or light emitted, a wave type that will move it from one place to another. I could, if I wanted to, connect an electrical wire from one place to another. If it was a battery to something, and that would be electrical current, would be my transfer. Or I could just push something along, and that would be the force being my transfer. So let's get rid of this thing for a second. I think I'm trying to give you all the bits, and it's making it sound more confusing than hopefully it is. So let's consider an object dropping from the sky. Okay, this object up in the air, and then halfway down here, and then it's going to hit the ground here. So this object could be a box full of AQA examiners. Now, up in the air, it's going to have a large gravitational energy store. And not much else, okay? As it falls, the size of the gravitational energy store is going to go down, and because it started moving, then the size of the kinetic energy store is going to go up. So I'm going to say gravitational store. I'm just going to try and cut my words down a bit for you. Gravitational store, let's put a little arrow down. Kinetic energy store. Kinetic store increases. And then when the box hits the ground, well, the kinetic energy store goes suddenly to 0 because it's hit the ground and it stopped moving. The gravitational store is now also gone completely to 0. Okay, in fact, and rather than putting those arrows, let's just put 0, 0, because now at ground level it's not above the ground, the gravitational energy is no longer being stored. Okay, it's all been transferred into kinetic, and now the kinetic has given it all away as well because it's stopped. So where has the energy gone? Well, we're going to have some sound, which is one of our transfers. So energy will be transferred away as sound. We will also, the collision will increase the thermal energy store of the ground. That collision will cause the atoms in the ground to vibrate more than they were before, therefore increasing the thermal energy store of the ground. It will also increase the thermal energy store of the box, and it's also going to increase the thermal energy store of the air around it. So this bang, this collision, is going to cause sound and heat, essentially. Now, it might be useful for me to try and do some kind of bar graph thing along the side. Nah. For the people who are because I've left this up here, this transfer. So I talked about this transfer here, the sound. I talked about the transfer here of the thermal energy of the air, the box and the ground being increased, but there's a transfer mechanism as it falls as well. And the argument goes that the transfer mechanism from here to here and from here to here is work done, because there is a force of weight pulling it downwards, so there is a work done idea here. The gravity is pulling the box down, the box has weight, so there is work being done dropping it down. But that is a really top end idea. Okay, I'd be surprised if they went that far into it. Okay, so I'm going to have a quick look at another example of an energy transfer, energy store idea, and let's just go for battery powered torch. I've drawn an amazing picture of right here with some stuff coming out the end. So batteries inside it. Remember I said batteries are not an electrical energy store. Electricity is a transfer, not a store. So what we have inside is we have a chemical energy store. Energy store, let's be precise with our words. Chemical energy store. Now there is a mechanism for that chemical energy to be transferred out, and that mechanism in this case is the electrical current. Or electric current. And then I feel like, now let's go across, and then that electrical current, we get this stuff coming out the end of the torch, traditionally called light. So light is a transfer, so the light is transferring this energy out into the world to go on and do its stuff. So that is a transfer. The other thing that's going on inside here is depending on the type of bulb, but let's just assume that we want bog standard boring stuff going on. There is going to be some heating in the wires, there's going to be some heating in the bulb to maybe make it glow depending on the type of bulb. So that heating means that there's going to be something thermal going on, and that thermal energy store, and we could say of the bulb, and then ultimately that is going to increase the thermal energy store. That heat, let's go for a different colour pen, that heat is going to be given out and it's going to increase the thermal energy store of the air surroundings. Okay, let's go with this, and we're going to write thermal energy store again. Well, and then I wrote of, but that's not on there. Let's go, just write a really snazzy surroundings here. Okay. In the good old bad old days, AQA really liked the phrase that the thermal energy from an object, whatever it was, your mobile phone or whatever, would dissipate to the surroundings. Now, this is exactly what it does. It dissipates to the surroundings. It increases the thermal energy store of the surroundings. So this is potentially a good phrase to keep. Okay, the thermal energy store of the surroundings is increased because the thermal energy store dissipates the heat out. Crikey, that's bright, isn't it? Thanks for watching. See you next time.